Okay, cool. Excellent connection. It's not bad. The latency isn't bad. It's not bad. Okay. Let's do it. Yeah, I'll just delete this and then send them my YouTube channel link. Go back to what I was saying. So back to what I was saying. This could be us what you're playing. Okay, these are the people I don't care about. Lol. Yeah, I guess I'll start. Should probably pull up like the chat, right? I can't pull up chat. Chat. Oh, does my computer heat up? Maybe it does. My computer is not built. Encoder overloaded. Turn down video settings. Maybe I'll remove it. Yeah. Encoder overloaded. Turning down video settings. Bro. Oh, hey, what's up? Cool. Okay. Oh, how are we gonna do this? I don't know. My computer can't handle this stuff. Huh. Whatever. We'll have to deal what we have to deal with. I'll just DM me on Discord. So let's just start. Actually, just give me a yes if you're good. You know what? I'll just start talking. Criticizing your stuff. I don't know. Whatever. I'm gonna start criticizing. So this is your account. Let me just pull up code forces. Hopefully it's not laggy. Is it laggy? Wait, please tell me it's laggy. Just like ask me if it's laggy. I know it's lagging right now. It's lagging a little bit. I really want maybe I don't know. But here's your account. Looks like you've solved quite a bit of problems. Quite a bit, yeah. Like 500 is a lot. But you notice that this 800 bar is far greater than the other ones. I know you've solved like quite a bit of these guys as well, but stop solving 800 problems. When you're doing practice, don't solve problems that are too easy for you. What is your rating again? think it's in dialogue. Or no, I think I friended you. I did. Okay, you're 800. So if I were you, I would do 900, 1,000, and 1,100, maybe even a 1,200. So here's kind of how everything good. Okay, just like keep on. Okay, whatever. Actually, do you want to see my face? You can see my face. I don't want. My CPU's not bad. Okay, cool. Where is it? Oh, video capture device. So back to what I was saying. This could, yeah, I need to open my lights. Wait a sec. Okay, let's go. Okay, this is what. Hopefully my computer does not crash. But here's kind of what's going on. So first things first, I'd say that you've solved too many easy problems. Yeah. And second thing second, based off the code that you've given me, I feel like you're overthinking a lot of things. So I should probably write this somewhere. It's gotta be a notepad online, right? Online notepad. Okay. Solving too many 800s. So when you're doing code versus contest, the first problem is going to be 800. So you're going to have to solve the first problem. Wait, how many problems do you usually solve? 0. Okay, that's tough. Okay. Yeah. So in order to break people, you need to be able to solve about 200 or 2 problems per contest. So that means your practice range should be from 800 to 1300. Actually, change that. This is going to be your practice range. You know what? And actually, I'm going to make this 1000. So there's going to be 2 types of practice. There's going to be speed practicing and normal practicing. Okay. Speed and normal. Okay. Ugh, they don't have tabs in here. Okay, speed practicing and normal. Okay, these are going to take only about 10 to 15 minutes. Okay, you should be able to solve these really quickly. And for these, you want to take about maybe 30 to an hour, 30 minutes to an hour. Those are the 2 types of problems you're going to be solving. Okay. These are the 2 types of problems you'll be solving. Yeah, that's kind of like the plan. So with code forces, contests can be like determined on your speed. This contest is actually a prime example of speed. I solved about 2 problems. I solved 2 problems in this contest. I did pretty bad actually. I was supposed to solve the 3rd problem, but I couldn't. It took me, like, I have to look at the editorial. But if you look at the contest, the people who, like, you could get up to like 1,500 rating with just 2 problems. So not a lot of people actually solved 3 problems. So yeah, this is my first thing. So this is my first piece of advice. So this is you're gonna have like a every time you want to practice at home, have a sort of plan, okay? And maybe do like one problem of this type, and 2 to 3 problems of this type. Okay, so this is going to be your training. Okay. As a newbie, you don't really need to know advanced data structures and algorithms just yet, but Yeah, breaking this kind of barrier is going to be tough, but I think you can probably do it. So you've done like 500 problems. You can probably do these as well. Yeah, so the next question is, how did I get to specialist and how am I still specialist? I tanked the last contest. Yeah, so I did pretty bad, which kind of sucks. But, oh, who's this guy? Interesting. Okay, cool. But yeah, this is kind of going to be your plan. I'll DM this here. Is everything working? Encoder overloaded. Maybe I have to delete this. Huh, I'm just going to delete it. My computer can't handle it. It's slow as hell. Everything looks fine. That's so weird. I don't know. I just hope it's not lagging too much. Computer is heating up. Yeah. But yeah, this is going to be what your practice plan is. So I guess we'll now. What? I'll also give you a book. No, this is not the book I want to give you. Oh yeah, you're okay. This book is pretty good. It gives you some tips too. Yeah. So 1,000 from beginner to specialist, from specialist to top 10 coder. It's pretty good. Highly recommend that. Actually, one thing I want to say. Is that I think you're overthinking a lot. Based on the problems or the code you gave me, you're making up like these very complex you're making things like harder than it needs to be. And with coding, you want to make it as easy as possible so you can debug it easier. Oh, you read that. Cool. Okay, cool. But I think you're overcomplicating a lot of things, which really makes things a lot worse. Yeah. So first things first, like try to think of an easier solution because usually the easiest is the fastest and the easiest to decode. Let's just like, oh, you have a blog. Maybe check that out later. But yeah, also fix your formatting. Your format should be like nice and easy to code or nice and easy to read because it can be very, very ugly if you keep doing this, and this could be a very bad coding habit. Yeah. So yeah. I guess what we can do now is solve problems by myself. I'll do a 1,000 problem. Yeah, math contests. Math contests are pretty cool. Like AOPS and all that. No, not Spotify. No, I don't want Spotify. RIP. Okay, Spotify's gonna pop up. And it's taking forever. Delete. Okay, cool. Wow, I'm lagging. Look at that. Okay. So actually, another good place is the use of code guide. Another place to practice problems, because if I were you, I'd practice problems like outside of code forces, so you can do multiple types of contests. I would recommend simulation problems. Simulation, complete search, kind of, yeah, basically all bronze. I'll recommend this to you. I'll just give this to you. So USACO, if you don't know, is the American equivalent of their Olympiad, their informatics Olympiad, and they got some pretty good problems on there, so you can practice. And they got a nice little book too. Basically, these bronze problems should equate to about 1,000 to 1,300 problems, or maybe even 800. That should be kind of the range. Yeah. Yeah. So I'm gonna do a problem, I guess. Should I do a really hard problem or a really easy problem? Give me a rating. Oh, cool. I'll tell you this, the highest problem I solved by myself without looking at the tutorial is 1800, and I got lucky with that part. How about topic? Oh, okay, sure, topic. Greedy, okay, interesting. Greedy, okay. So greedy tends to be tough when, I'll just do 1,500. That's kind of like my range, maybe even harder. Actually, I'm gonna go 1,200 because some of these problems below 1,200 are kind of too easy. Yeah, so greedy, yeah. So, okay. I'll show you my thought process, and I'll start with just inflation, I guess. Yeah. Greedy, yeah. You know what? I could probably assign you problems as well. Where did I go? Wait, I want to see my live stream because I don't see the comments. I don't have the comments pulled up. You can see my creator studio. Is it overloaded? Yeah, it is overloaded. I can't find the thing. Content. Live. There we go. Live. View in live control room. Let me just make sure I'm not goofing off and lagging. Oh shoot, it's not smooth at all. You know what? I could probably assign you problems as well. Okay. Oh, you're inconsistent with 800. Interesting. Okay, that's tough. Okay, I'll pause this so it doesn't matter. Okay. I'm gonna take out Discord because it could be slowing down. Okay, this should be. Am I overloaded still? Okay. Cool. I'm gonna do a problem. Okay. Yeah, my encoder is not overloading. Cool. Okay, time to do a problem. Oh shoot, my caps. Actually, no, I'll just do it. You have a statistic of price changes for one product represented as an array of n positive integers, where PO is the initial price of the product, and PI is the price increase during the ith month. Using these price changes, you are asked to calculate the inflation coefficients for each month as the ratio of the current price increases by pi I to the price at start, or increase PI to the price at the start of the month. Your boss said you clearly that the inflation coefficient must not. Ugh, so much reading. More obvious cheating. You can minimize the total sum changes. Ugh. Okay, so when problems are like boring like this, I usually just go and look at the test cases and see what's going on, see if I can find any patterns. She don't care unless it benefits her budget. I got test cases. So this is my template. I copied it from Benchy. Yeah, well, so if I were you, I would get a template. So actually, I'll type that. Makes things a lot faster. Unless it benefits our budget. First line, each test case contains N and K. Okay, so with these problems, you want to notice like the N size, and you notice that N is actually pretty small in this case. So there is a possibility I can use O of N cubed. Yeah, O of N cubed is actually possible. Oh, you have one. Okay. Okay. Everything's working fine, right? Encoder overloaded? What the hell? Dude, I swear, I literally am raging. I don't know, I'll have to leave it like this because this is the lowest that I'll probably go. First test case, you can, for example, so this is N1, you can increase PO by 50 and P1 by 49 and get the array, blah, blah, blah. Wait, what? You have a statistic? Wait, answer what? You have a statistic of price changes for one product represented as an array of n positive integers, where PO is the initial price of the product and PI is the price during the ith month. Okay. Using these price changes, you are asked to calculate the inflation coefficients for each month as a ratio of the current price increased. Is how the price was increased. Okay. Your boss said you clearly that the inflation coefficients must not exceed K% so that you decide. Okay. Okay. So the first guy is the original cost. Oh, K percentage. That's why it's an integer from 1 to 100. Interesting. Oh, that's probably be annoying as hell. And the first test, you can, for example, increase PO by 50, 49, and get the array, blah, blah, blah. Right, so the minimum number of changes. Okay, so the number of changes 50 and 40 plus 49. I see. Okay. What deep is that? Oh, this is gonna hurt my head. This may be annoying. and everything's working fine. Am I missing something? Okay, and then entries. Okay. Or, so this is just taking input, nothing special. Actually, I'll change this to key just to keep it coherent. The first one's going to be your actual number, though. It's going to be the beginning number. You know what? I'll just... No. So what we'll need to know is the max amount of change needed. For example, this has to be 1% of the total number. Okay, so these changes have to be less than 1%. So in order to find out how much percentage it is, you have to multiply by 100. I actually don't know what to do with this one. Does that matter? Your stream is blurry now, good. Okay, now good. That's weird, man. My stream is so stupid. I hate my streams. Is it really blurry? Oh wow, it's blurry. Oh my god. I have to read this? Dude. Ugh, I may just use a higher scale resolution. I don't know, man. What could I do? What could I do? That's done. Okay. So we need to know which number is greater than the required amount needed. For example, start drawing up math actually. So we have the original price. Then these are percentages. I'm taking so long for such an easy problem. Times 100 per. Dude, I'm not working right. That's 2. Okay, if it's 2%, what's my ratio? It's gonna be if I just multiply the percentage by 100, it's gonna be that's the required for 1%, 2%, 2%. I'm so tired. Okay, I'm gonna do. We'll divide. Oh no, but that means we'll have to use decimals. God. Okay. We'll multiply these numbers by 100. Then Also multiply by, we'll multiply by k times 100. Is that right? 2 times 100. What am I going to do with that number? No, I'm going to have to use a lot of decimals. Fudge, man. And these numbers can go to 10 to the 9th. What if it's like 3 and I can't divide it by 3, dude? Whoa. It feels like math. It feels like math. Oh, everything works. Nice. Damn, why am I so bad at coding? I can't do it at like 10 p.m. It's too late for me. I have a good sleep schedule. I feel like it's math as well. I'm just gonna go for a solution. Alright. Actually, so we want to find the maximum required for it to be a percentage. So we want to find I need to find a certain number. I just don't know how to explain it, and I don't know how to write it out. I just need to clear the canvas. Oh my god, it's yellow. My least favorite color. So x over total has to be less than or equal to k over 100. Am I right? Yes. This is what I'm looking for. So this is the formula I'm looking for. So multiply both sides by this. Okay, I think this is what I'm looking for. Okay, I'll take the maximum of 100 times x divided by k. And it'll have to be a double because I don't think everything's going to be divisible by each other. So I'll do that. Is there negatives? No, there's no negatives. So what am I going to do? What am I going to do? What am I going to do? Okay. So back to what I was saying. Bruh. What is this called? Inflation? Code forces. Please load. Why are you so slow? No code overload. Cool. So, okay. I'm going to take the max. Multiply by 100. Yeah, let's just whatever. Let's just output this. I just want to see these. Oh, I want to output a max as well. Shoot, I forgot to do that. It's going to take forever to compile. Oh, wait, there's a compile error. So back to what I was saying. Okay, it's not declared in the scope. I capitalized it. Okay, so I don't know what I'm looking for. I need to write it out. Oh, what is going on? Oh. And a compiler error again. Oh. Did I do that? I just want to cast it to double, it should be fine. I think it's fine. Everything good. Everything's good. Give me 2100. It's gonna be my max. Did I multiply it right? Oh wait. I have to do it by 1. I have to skip the first index. Because the first index doesn't count. So actually this does work, so good. Yay, go me. 2200 or 2000 or 20,200. Any columns? Okay. So this is gonna be the max amount of this is gonna be the amount I need to increase by over. Actually, I should probably make array like that. Subtracted by that. Okay, I have an algorithm. Okay, I have an algorithm. Okay. I have an algorithm. I can't say it out loud because I don't know if it works, but I have an algorithm. I have an algorithm. I have an algorithm. Seal of change minus PO. I want to keep the original. This is gonna be good, boys. This is gonna be good. This is gonna be good, guys. This is gonna be good. Because I don't want to deal with that stuff. If we'll seal change minus P, this should be good. So this is the ceiling subtracted by the burning guy. Yeah, this is the amount I need to change. This problem is weirdly worded. Did not like how it's worded. Do not like how it's worded. Go back to what I was saying. This could be us, but you're playing. I might change anything. 303? What are you doing? Oh. Stupid. It's gonna be us, but you're playing. It's gonna be all that you're saying. Should be good, what you mean? Still 100. Why are you 100? feel bad for the people watching me. It's kind of cringe. Shut up. It's gonna be a switch you're playing. Okay, wait, I'm overcomplicating this. I'm overcomplicating things by quite a bit. $99, cool. That's gonna be us picture playing. That's all I was saying. Let's do like a sample test case or a test. 5, 1. Actually, I don't want it by 100%. I want it by 1%. Yes. Oh. Is that right? I have to add 199 to be to 200. Then I'll have to add 200. I'll have to add another 100. So 200, 300, 400. Yeah, it works. This problem is not my favorite, nor it will be my least favorite, because I have seen some worse. Wait, I always gotta play CF notifications.
Problem B got wrong answer test 2, sir.
A rip. I didn't get 2. What could I have done wrong? You know what? Let's look at test cases. What could I possibly have done wrong? First numbers differ. No, not first numbers. Five, 2, 2, 2, 4. So start with 3. In order to have 3% 2, it's going to be see, like, you have more room for 3%. That's my issue. More room. Oh, yes. Okay, I do encompass that. 5, 3, 3, 2, 2, 2, 4. Two, 5. Why is 4 so big? Oh yeah, it does need double. Oh, there's probably some gradient. Percentage over thing should be good. Four times. Four over t, which is the total. Total being wow, it's late. Could it be that it's off by 1? This problem makes my head hurt. What was this problem? Is education good? What was it here? I would have done pretty bad on that problem. Aha, I got 25. Does it pass test cases though? It does. Please stop. Okay, maybe inflation might be correct. Wrong answer on test 3. Now what? Numbers differ. Ooh. Overload? No. Oh, overload. Dang. Oof, overload. I think it's overload. Yeah, it's overload. Or overflow. Okay. I know what we can do. Multiply everything by 100. Or everything by k. So this does not have to be a double. Then ends to okay. Or I wanna get this work. So back to what I was saying. Maybe it's maybe it's 4. I don't output anything, do I? Fall, so we fall. Wrong answer on test case 2. Oh, okay. Bet you I'm off by like a couple. 30. Whoa. Got overload here. So I think I got the right answer, but my overload. Oh, it's vector. Oh, wait. This could have been good. Wait a second. Change this guy to int or long. Vector double should be able to hold it. What I could do is multiply change by k. I don't know, then there will be some issues. I don't know, we'll see. We will see. No. AC. Yay, AC! I did it. It took a while. Binary search? Wait, what? There's binary search? Wait a second. There was binary search? Like, oh my god. login for test case. Yeah, I use long double or but what if k wasn't divisible? What if you couldn't divide k? Exapoleno. Oh, plus k minus 1. So he did round it up. Okay, he did. Yeah. Oh, interesting. Works. Thanks. Took forever. Interesting. He took sealing. Okay, so let me explain the solution. Yeah. I'll explain. Okay. Sorry. You just watched me ramble for like an hour. Here's kind of how the solution goes, because this problem is annoying. Like most problems, it involves doubles. Yay. Yay, I love doubles. No, I hate doubles. Doubles are so goddamn annoying. Okay. So, okay. So, this is why I hate doubles. Because of overflow. But somehow I didn't get overflow. I think there are ways to avoid it. I just got lucky because long double also works, but whatever. Okay, so here's what's gonna happen. You're given, let's give the, actually, there was one test case that was really good. I want to pull that one up. This one. 5, 3, 3, 2, 2, 2, 4. Okay. So usually I wouldn't look at the test cases, but this problem's kind of annoying and I didn't want to like overthink it. Because you can't, in a problem or in a contest, you can't look at your test cases. So that's like cheating. But so you're given some numbers and your goal is to, so this is your starting number. And your goal is to, yeah, so your box or your, let's see, how do I explain this? Your, okay, so imagine you have like, okay, so your number is going to increase by these guys. So this is going to be your starting number, start, these are going to be your increase. Like these numbers are going to increase your original number. This one's so hard to explain, golly. So you also have k. So k represents a percentage. And your goal is to your goal is to make it so that the percentage between, or I made an equation actually. So I'm going to say this is AI. Okay, sorry, this is not going to make a lot of sense at the very beginning. It won't make a lot of sense. Current less than equal to k over 100. Am I right or am I wrong? Okay, so your goal is to make it so that okay, you start out with the current amount, so it's going to start out with 3. And when you iterate through these people from 1 to n minus 1, your goal is to make it so that AI is less than your total current. That's basically the idea. So current is going to be your accumulation of numbers. So it's going to start at 3, you're going to 2, gonna have 2, and then you're gonna have 2, and then you're gonna have 4. Okay. And the issue is it has to be under K%. Okay. So this guy has to be under K%. Or the fraction of this over the current has to be under K%. And in order to do that, you can increase your current. So you can make your denominator larger. And your goal is to find the cost. So your cost would be how much you have to increase your denominator. This is so hard to explain. Stupid problem. Yeah. I'll just keep on going though. So in order to basically solve this problem, you'll notice the pattern. It's hard to explain. Yeah. So obviously 2 over 3 is greater than, or is not less than 3%. So what we got to do is we got to increase this total so that it matches this. Okay. And the minimum cost would be, in order to determine the minimum cost, it would be, for this example, I would like to isolate AI actually. Actually, no. Yeah, I would like to isolate AI. 100 AI, A to the current. Okay, you probably will not understand this. I have no idea if people will be able to. Wait, maybe I'll isolate current actually. AI. Okay. So the current has to be greater than some this kind of equation in order for your equation to hold. That's so hard to explain. Okay. So yeah. So for example, let's find current for the first example. So K is still 3. 100 times AI would be 2. And that would be 203. And we'll round this guy up. So we'll have 67. So yeah, current has to be 67. So what you would do is your answer is the cost. So since you already have 3, you have 67 minus 3, which equals to 64. This is a terrible problem. It's so hard to explain. Why did I choose this one? Anyways, so yeah, your goal is to increase the first number such that the percentage, or K percentage, of this number is the percentage is less than the increase divided by the current. God. Yeah, and the greedy way to do it is to find the highest possible or the easiest way to do it is just to fulfill this equation, isolate current, and then iterate through these guys, and keep on adding to the current when you need to, or keep on adding to the answer if you need to. You know what? I'm gonna skip this problem. This problem sucks. I'm not gonna lie. I feel bad, but this problem sucks. I'm moving on. You suck. That's math. You suck. Minus 3. It's 67 minus 3. So because you already start out with 3, and your goal is to get to 67 so you can fulfill this equation, right? And you already started with 3, so you only need 64 more to go to get to your card. Again, this is a terrible problem. I hate this problem. It's so complicated, and I don't know why it's 1300. It could be even harder. I don't know, dude. I'm gonna do another greeting problem for you. I'm gonna do an easier problem so that I don't have to stress out this time. I'll do 1000 to 1200. I really don't feel like doing a hard problem. Usually, I'm supposed to challenge myself, but I'm sorry. Okay? I can implement. Wait, did you understand? Holy shit! Wow, you understood? Dang. Okay, I'm so sorry. Well, okay, I'll get to implementation then. So I made a vector. So you use arrays. You use arrays a lot, but I like vectors because you don't have to define how large your array has to be, and I can literally just set it to an amount. And then this original does not matter actually. Let's look at that. This also doesn't matter. So I'll loop through 1 to n-1 because those are the only numbers that matter. And change is going to give me how much I need to change from p0 in order to fulfill the condition, this equation. I do math. So in order so change is the amount you need to fulfill this equation. Or yeah. And so what I do is I take the ceiling of it. Actually, a better way to do this instead of using doubles would be this. Okay, this is going to be the ceiling. This is just the ceiling. If you want to look at the code, it's this. It's really good. All is long. It just gives me the ceiling, basically. It's really fast and it's really nice. So I get the ceiling of it, and then the change is how much I need. So I just add the difference to ands, and then I change this to the ceiling. And then, yeah. I also add whatever like increment I need as well, because I also get that from the inflation. So every time I go through a number, yeah, that's kind of what it is. If you don't understand, just DM me. A broken problem. Damn. It's already been an hour? Oh my god. I don't understand the implementation? Oof. Okay. How do sure, yeah, just, you can go on my website. I don't think I can, or not website, go on just my account. But this is Ben Sheets. I reread since I'm doing school right now. So what do you mean reread? Oh, yeah, sure. Right here, I'll send it to you. Here you. I'll make some edits. There we go. Okay, I'm gonna do some harder problems. Wow, that's blurry. There we go. Okay, I'm gonna do some harder problems. Okay, cool. Actually, isn't too bad. Okay, I'm gonna do an easier problem. You know what? I'm gonna do that problem I just did, and it'll be. I don't know. Implementing is like a skill you need to learn, and it takes a while, but once you get it, you'll be very happy. Like you'll be better at it, I guess. I mean, once you have it, it's gonna be very useful. It takes a while to learn. The student council has shared a document file every day, so members. However, one day the members somehow enter the sequence of the document at the same time. TMT. Let's just say yes. Oh, interesting. Oh my god, interesting. Oh, okay. So your goal is to delete. Wait, why is this no? You have TMT right here. Wait. However, one day the member somehow entered the. Oh, okay. Sure, you've done it. Okay. I like that problem too. Rope. I'll tell you this, implementation is my least favorite. It is my least favorite of the bunch. It's my least favorite. I'll do coin rows. This is game theory. Fudge. Alice and Bob are playing a game on a matrix. So start on 1-1 and you move down to 2M, I see. You can either move right or down, and you can only move right once because if you move it again, there's actually no more. Actually, wait. Oh, okay. It's stupid. It's comp side and stuff. All our moves, she collects all the coins, such. I see DP, but there's no DP. Wants to minimize the score, while wants to maximize the score. What is the score of the game? What will the score of the game if both players play optimally? Score of the game is the total. Wait. And collects the coins that he visited, but Alice didn't. Okay. I don't get how this is implementation though. I do see a greedy approach. Wait, you've done it too? Okay. Wait. Dang, it's got a lot of problems. Holy schmoly, bro. Buffering. Dang, it's got a lot of problems. Holy schmoly, bro. Buffering. Dang, it's got a lot of problems. Holy schmoly, bro. Oh my god, it's going crazy. Maybe I'll take out the output as well. And where she walked down and falling. Two people. Oh. I'm trying to. Oh, one tip I should tell you is you shouldn't do tags. You shouldn't show your tags because that gives away spoilers. And when you're doing a contest, you're not going to know what type of problem you're going to encounter. And it actually makes it significantly harder. Yeah, sure, I'll do it. Let me check out what rating it is though. Because if it's above 1500, I may have to look at that tutorial. Bruh. Anime picture. Bruh. Dude. I may not be able to do it, bro. I may not be able to do it. Oh, wait, let me just DP in trees and brute force. Let me see. It's A. Holy schmoly, bro. DP trees, damn. You gave me a crazy problem, dude. You crazy, bro. You crazy. Let's see what we got here. Painting the fence. Alright.
早点睡觉，明
Oh,
儿早
okay.
上要起。
Okay. My parents just came in the room. They were asking me you should go to sleep. So I'm gonna keep on doing this problem. I may stay up even more, but whatever. Okay, so 1700 is a little bit hard, but I can do 1700. It's not a problem. And you do what you gotta do, you know what I mean? So we're gonna try it. I'll try it. Okay, so you have a log fence consisting of n sections. Unfortunately, it's not painted, so you decide to hire Q painters to paint it. The Ith painter will paint all sections X, such that. Okay. Fortunately, you're on a tight budget. You can only hire Q minus 2 painters. Obviously, only painters will paint. You want to maximize the number of painting sections if you choose. Interesting. Okay, interesting. Oh, excellent connection. Bangers, bro. Bangers. Okay. Four, 5. Whatever. 5, 6. 6, 7. And then 6, 7, 3, 5. 3, 5. Okay. You hire Q minus 2 painters. Or actually, I just need 1, 4, 3, 5, and 6, 7. Interesting. Okay. Okay. The first thing I'm thinking of is sorting. Getting everything in order will make things a lot easier. Yeah. Actually, this is greedy. Wait. Can I do n squared? Maybe I can get away with n squared. Wait, why is this so slow? Wait a sec. Maybe I can get away with n squared. Could be able to get away with n squared. Could be too slow. I don't think it's actually DP. I don't think. Could it be DP? Selected or not selected? Yeah, I don't think it's a DP, dude. I don't think it's a DP. No, it could be like knapsack. But I don't think it's a DP. It's also brute force, which shouldn't be on. Let's sort P. DP from my experience. Yeah, it looks really easy. I don't know what's going on. Yep, I'll just take the minimum distance. Okay, so what I'm gonna do, I'm just gonna call it curve. Why is it giving me oven squared? This is giving me really bad vibes. Oven squared. Oh, and sections. Okay. Wait, no, it doesn't matter. Why is it? You know what? I'm just gonna implement my own idea, but it's not n squared, and that's really giving me very bad vibes. How old is this problem? Oh wow, it's old. For a while. Oh wait, actually it's pretty hard. 1 to 4, 4 to 5, 5 to 6, 6 to 7. It's too late for me to do this. What's this? One, 2, 2, 3, 3, 3, 4. Can only 2. Is the maximum. Wait. You know what I can do? Wait, no, I think I have a different idea, don't worry. Alright. It is only... Yeah. I have an idea. I'm going to be very, very annoying. Not annoying. Place all these zeros. I can use oven squared. I'm going to assume this is oven squared. Okay, I'll decline. Worst thing I've ever Okay, so I'm going to add a counter array plus plus. Sorting actually doesn't matter. I don't care. Yes. What's this called? Painting the fence. This could be really easy. Oh, is this oven cubed? Oh, this could have been so good. Shoot. Range queries? I can do range queries in log time. I can use a sig tree. Let's just make sure this works, and then maybe I can speed this up somehow. Please don't get the... Just in case. Okay, this is my brute force solution. So like with these problems, kind of like a good way to start if you don't know what to do is do brute force. And with the easier problems, the answer probably is brute force, but this is probably not going to be brute force. It takes me a lot of time though. Wait. No, I took out test case. NQ. What's Q? Not N. If this works for all test cases, then I can speed it up. 7. What is going on here? Okay, out of bounds error. Alright, something's giving me out of bounds error. Something's giving me an out of bounds error. Load. Okay, not even that. Something's wrong. Oh, it's Q. Oh, it's Q. And these two are Q too. I'm so used to putting N here. It's Q. Because we're going through all the payers. Oh my god. Can I just do length brew? I don't know why this worked then. This should not have worked. That should not have worked. 2. Five. No, no, no. That is not supposed to be 5. Three. It's 3. Wait, why is it 5? It shouldn't be 5. Okay, continue. I don't want you. Ugh. Oh, I'm an idiot. Look. I'll have to add it back when I'm done. Oof, oof. Or, wait, I don't need to change that. I'm just gonna add continue back. Continue K plus plus. And I should be good. Actually, I can probably query in one time. Oh, one time. Not necessarily update. I just need query. Yes. Okay. Cool. Okay. So I need an operation that can update all values. This is fine. Yeah, it's fine. I also need an operation here that can prefix sums. No, I lose too much information with that. Give me some data structure. The thing is, I don't want to subtract now. Actually, alright, let's subtract one number by 1, right? Actually, I only need to do I once. That's already way speeded up. I need another temp. Problem is O and square, or in cubed, and I'm not good with O and cubed, aren't I? You know what? Fuck it. We're gonna sim it. Wait, let me just make sure I'm not making a fool of myself. I did make some significant changes. I want range update range or range. Oh my god, it's 12. What the hell? Or I want range update. I want range update. I want range update. The problem is if I use like segment tree or what else is range update? Binary index tree. I feel like it'd be still too slow. This is in cubed. I query this part. I query this range. I query this range. Or I query that range, and then I have to add it back as well. High load. Cool. Okay. You know the minimum of an area. Actually, I need to count the number of ones in that area. I just need to know how many ones there are in my count array. I just need to know how many ones there are. number of ones from I have ones and then twos and then ones. This is the kind of deal we're looking for. I can do prefix sums. Number of ones and number of twos. So I actually need to know the number of ones and the number of twos. So I can do prefix sums. So pre n. Let's do n. Ones, 3, 2s. And that's right. Okay, I'm almost done with this. I think. What? That's not healthy for my keyboard. This is like late night coding for like no reason. This is way too late, bro. I have to get up tomorrow too. That's actually a big lull. Yeah, everything's one indexed. I'm an idiot. I can create its own of and O of one time actually. I just need to rewrite this. Actually, sent. Number of ones. I'm a little. Okay. I need to find the intersection between these two segments. So I have the beginning and end segments of these guys. I need to find the intersection. This is D. So how do I do that? How do I do that? Okay. To do some casework, which sucks a lot. Back to what I was saying. This could be us, but you're playing. This could be us, but you're playing. Yeah. No. Actually, just see. Number of ones. On the other side, which would be B. This is getting really complicated. gonna try to count number 2's. So 2's is the intersection, which is B between C. D minus 1. So B is greater than D. It's not, it's D. This is when it's fully intersected. Okay, this is O1 query. It should fit the time limit. I'm a little worried about TLE. I'm actually very worried about TLE. I'm panicking right now. Why are you slow? Oh. Oh, it's P. Got 7. Got 2. No way I implemented this first try. You're capping. No, you're lying. I did not implement this first try. I've made some mistake. Dude, I've made some sort of mistake. Dang, he's still watching? Wow. There's no way I implemented this first try. There's no freaking way. I got wrong. I probably got wrong. No way. No. If I get this right, I will fucking panic. I will panic. I will panic. I will panic. Stop. Stop getting it right. Stop getting it right. Oh my god. Stop. Stop getting it right. I implemented this first try. There's no freaking way I got this right. Why is there 200 tests? Tell me, why is there 200 tests, bro? Why is there 3? Holy smokes, I did it. There's no way I got this first try. Oh, his is much more less complicated. Wait, how do you do this in OV? Wait, this should be done in OVN. I don't know how either. I thought I wouldn't pass time limit. It says ov n right here, but I did ov n squared. Bruh. I did this ov n squared. We'll see this, bro. I don't know how. I don't know how. I don't. Oh, the prefix sum should be done in ov n. Not the whole thing. How did I implement it first try? How? How? Dang, I must be a genius, dude. I must be a genius. Oh, DP program. I need to improve my DP. Start my YouTube channel. This guy seems cool. He's like a competitor though. You know, I gotta make good YouTube channels too. Good YouTube channel too. No, I got lucky. I got lucky, dude. I got lucky. I got really lucky on that one. I'm pretty good at prefix sums though. But I still don't get, is this ov n time? I think it is ov n time. I think it was ov n time. I don't know how I passed test cases though, or I mean time limit. Because I shouldn't have been able to time limit it. I passed time limit. How? How did I pass time limit? What the hell? How did I pass time limit? I'm trying to figure out how I pass time limit, but max. You've done something weird. Could have been like take the painter with the least amount of effects. Don't know. Yeah, I have no idea, man. I'm also eating watermelon, so whatever. I somehow got it. I don't really care anymore. This had like 300 test cases. Holy smokes. Passed all 300, so. Look at this. Let's scroll down. 294 test cases. God damn. The question is, why is it ov n? Why mine is ov n squared? Let's see other people's solutions. Yeah, look, people took like way less time than me. No, this guy was slow. What did he use? Yeah, he used a DP. Oh, same thing I did. Perfect sum. What does this guy use? Yeah, double for loop. Oh, weird. Weird. Don't know. Whatever. Oh, I should probably explain it. Wait a sec. So how painting the fence works is I basically did brute force. I think it did spoil the thing for me though. I basically did brute force. So I fixed these two positions. So like I noticed that I could do n squared because it's 5,000. 5,000 is like whenever you see 4 digits, you see n squared basically. Usually n squared can fit for about anything 700. This is n squared. Usually anything less than this. If n is less than or equal to 7,500, you usually can do n squared. So keep that in mind. Why am I lagging? So yeah, so I noticed that, and what I did was basically I fixed these two positions. So these two are going to be the two painters that are going to be taken out. Next one number. Okay, these are going to be the two painters I'm going to be taking out. And what I noticed is that the answer only decreases when you, so first things first, I take in the total amount. So the total amount is going to give me, like if I had all of them, if I had all the painters, the total is going to be it. And then what I do is I notice that in an array, my answer only decreases if okay, so actually I should probably, so this is a continue or a count array, and this counts like how many painters have painted this area, because each painter can only paint each position once. Okay, and so a good way to explain it would be, I guess, how about this. Actually, so instead of imagining it like a line, imagine the problem like a array. Okay, they all start out with 0. So I'm going to do the first sample test case. And when 1 4 goes in, it's going to go like this. It's going to change these 4 numbers to 1. And you're going to keep on doing that until all the painters are done. Okay. 2 1 2 2 1 1 2 3 3 2 1. Okay. So this is going to be my ending. Okay, so 1 1 2 3 3 2 1. So this is going to be my count array. So that means 2 painters have painted index 3. So 2 painters have been painted. Right. Do you know perfect sum? Because that is required to know this problem, that data structure. Okay, so yeah. Okay. So what prefix sum it does is it can give you static queries. Static queries. And what static queries means is it's a query that relies on an array that doesn't change. Okay. And these queries can be O of 1 time, so this can be really fast. And so the goal of prefix sums, the goal of prefix sums is to get a range of numbers, like consecutive numbers, and get like a certain query. Okay. And what I can do is I'm going to make two prefix sums. One that gives me the count of ones, and one that gives me the count of twos. This will be in parent y. Okay. So the count of ones, it will give me 1, 2, 0, and remember it's prefix sum, so it's going to continue. And then I see another 1, so I add it by 1. So I'm going to start at 0. This should be like, so I start at 0, and whenever I see a 1, I increment it. And if I don't see a 1, I'll just add the guy before it. And I see 1. So that's kind of how prefix sum works. This is going to count the number of 1s, and this is going to count the number of 2s. Or actually, I'm going to model it like this. So I see a 2, or actually these are going to be 1s. I see another 2. Yeah, notice how it only goes up. Okay. And with prefix sums, if I get a range, right, like let's say I want to find this range, all I have to do is take 3 minus this guy. So the very last dude minus the last guy minus 1, and then that would be 2. And that means there's 1, 1 in here, and there is 1, 1. So with prefix sums, it gives me a query that allows me to find the number of ones within a certain range. And that is through count ones r minus count ones l minus 1. And that gives me the number of ones or twos, if you want to use count twos. And this is important because the only way to decrease an answer is by having an index with either 1 or 2. Okay. Because there's only one painter, or since only up to 2 painters are used or taken out, since you only take out 2 painters, yeah, 2 is the largest. So I'm going to copy this down here. Okay. So now, what I'm going to do is you basically iterate through every possible pair of painters. So let's say I want to choose, let's say I want to choose the optimal path, which would be to choose, I think it was 5, 6, 4, 5 actually. So 4, 5 is this segment, and 5, 6 is this segment. So you'll notice that there's like an intersection right here. Okay, so that means I have to check whether this little intersection is, or the number of 2's within this intersection. And then I'll have to check the number of 2's in here. Or number of 1's. I don't understand. It seems like this problem's too hard. It is really hard. This is fit for a 1700. But I'm also explaining it really terribly, and it's also very late at night. Yeah, okay. So if you want to solve this problem, you need to strengthen yourself in prefix sums. Okay. And the only way to decrease your answer is to have numbers that are either 1 or 2, because you can hire up to 2 painters. And remember, each number represents the amount of painters that painted over the area. Yeah, I'm going to stop explaining. I don't know if I can explain anything really well right now. I'm pretty bad at explaining. I don't know. Maybe it's hard to like ask questions. Yeah, I'm kind of tired too. Do 1002 problems. Don't worry about writing too much. Have fun first. And then you'll start to enjoy like computer science in general. You'll start to enjoy competitive programming and all that. Because the first thing you want to do is have fun. Enjoy like what you like. Enjoy this problem more. You know, you saw me freaking out when I submitted the problem first try and I got it. Enjoy it. Yeah, just try. If you don't like it, I don't know. I mean, you can get a lot of good jobs, so I guess it'll be like work. But you know what? I'm gonna do another problem. Should I do 1800? Actually, it's no fun ranking down. It isn't no fun. I ranked down too, and I had no fun. It's tough. It's gonna happen. I remember for a very long time, I was kind of like you. I couldn't solve a problem. And then I got, this Div 2 was really lucky. Div 3, and then I went back to solving 0 problems. 1 problem, 2 problem. And, you know, there's actually a huge gap between these two. I barely practiced between these two intervals. But yeah. I still have a lot to go, a long way to go, but I really practiced this summer. And I'm glad there was some results. So, but yeah, don't worry, man. Everyone starts at the bottom. Can't sleep. I'm gonna do another problem. I just feel like it. Oh, want to see me? Actually, no. Before you leave, wait. Did you leave? Okay. Before you leave, I highly recommend this kind of place. You've probably seen it though, but just like read some articles. These algebra ones are pretty hard to understand. I like to go to like these guys. Data structures, string processing. I've been telling myself to read it, but I keep forgetting. Combinatorics. I'm not good at combinatorics, but I need to get better at it. But yeah. You know what? Want to see me do another problem real quick? And this won't take too long because I'll do something that like a 1000 because this is something you should be able to solve. Wait, no. Ah, tough. He has to go. Okay, I'll do a quick 1000 just for fun. You may not be here, but I'll do it for you, man. Is he still here? Wait, is he still here? Go to... Oh, someone's still here. Concurrent errors. Ugh. Tough. He has to go. Okay, I'll do a quick 1000 just for fun.
You're capping.
Okay, you can
No,
leave. I'm gonna watch myself.
How? How did I pass time limit? No, if I get this right, I will fucking panic. I will panic. I will panic. I will panic. Stop. Stop getting it right. Stop getting it right. Oh my god. Stop. Stop getting it right. I implemented this first try. There's no freaking way I got this right.
Oh, that sounds so
Why is there
stupid.
200 tests? Tell me, why is there 200 tests, bro? Why is there 3? Holy smokes, I did it. There's no way I got this first try.
I'm lagging. I'm slow. Oh my god.
Hang on.
Whatever. Okay, see ya, dude. Maybe I should do. Gold. Could do a use code problem. Oh, I need to practice Fenwick trees. Ugh. Yeah, I need to practice Fenwick trees. That's ordered set. Oh, lazy update or lazy segment trees. This looks good. Is Benchy off? With Fenwick trees, what do Fenwick tree to do again?